Okay, so we'll have a look at the solutions for the FTC2 part. So this was finding the derivative of the functions, but the functions were given as an integral. Okay, so number one, g of x is equal to the integral from 1 to root x, t squared over t squared plus 1 dt. Okay, so g prime. The first thing we do, remember the derivative and the integral cancel out, and then that top part gets substituted in. So we're going to have root x squared, so that will be x. Again, root x squared, that will be x plus 1. And then we need to multiply by the derivative of the top part, so that will be 1 over 2 root x. Okay, so this is the short way of doing things. If that's too much for you, you can do the longer way with that u substitution like we did in class. Okay. If you would like me to go through the longer way with you, please just see me in my office afterwards. Okay, and then we can go through it one-on-one. Okay, so that's number one. Number two. Okay, we have g of x is equal to integral from 0 to 2x, e to the t plus 2t dt. So g prime. Okay, first bit we substitute in. So you can think of like that 2x as the u, so you would substitute the u in, and then you'd have the du by dx at the end. So that would be e to the 2x. Sorry, that's an x. Plus 2 times 2x, so that'll be 4x. And then the du by dx, in this case, it will just be a 2. Okay, so you can leave your answer like this, or you can multiply it out. Both are acceptable. Okay, so don't do any extra work if it's not really needed. Okay, number three. Someone asked a question? Yeah. Sorry? Too fast, yeah. If I'm going too fast, please just let me know, right? Because if you don't have questions, I'll just carry through. Where did I lose you? Okay. So here, this 2x, that was our u, like we did on the Monday. So if we're finding the derivative and the integral cancel, so we're just substituting the u in. So e to the t becomes e to the u, but u is 2x, so it's e to the 2x. And then 2 times t, that becomes 2 times u, but u is 2x, so it will be 2 times 2x, which is 4x. And then once that's done, we need to do the chain rule. So on that far end there, that is d by dx of 2x, which is just 2. Okay. So here, this bit, this is dg by du. This bit is du by dx. So that's just the chain rule. Okay, I encourage you to just put everything in brackets like this. So the first part, put in brackets for your dg by du, and then the second part, the du by dx, put in brackets as well. It helps, separating the parts. Okay, number three. So we have g of x is equal to the integral from x to x cubed cos of t dt. Here we can't do things directly like before because the bottom part is a function of x and the top part is a function of x. So we need to split it up first. So a little bit of working before. We have the integral from x to 0. Again, that doesn't really matter what it is, as long as when you substitute it in, it's defined. So you can choose 0, you can choose 1, you can choose pi, anything's fine. Okay, cos of t dt plus the integral from 0 to x cubed cos of t dt. So cos. Okay, now for that first one, we see that the x is at the bottom. To use the FTC2, we want the x at the top. So we swap the bounds, but then we need to put the minus sign. Okay, so this is minus the integral from 0 to x cos of t dt plus the integral from 0 to x cubed cos of t dt. Okay, so now everything is looking fine. We've got the x at the top and the x cubed at the top, so we can use our FTC2. So g prime. Okay, for the first one, straightforward. We don't have to worry about any u substitution. We just take the x, we put inside cos, and remember the minus sign in front. So minus cos x. Plus, for the second one, we do need to worry about the u substitution because the top part is not x by itself, it's x cubed. So here we call this thing u, that top part. So we do d by du and then du by dx. So let's do the d by du part first. So we're just going to have cos of u, and then the du by dx, that will just be 3x squared. But we can't leave it as cos of u, we need to put the x back. So since u is equal to x cubed, that cos term over there, that will have x cubed. So that will be cos x cubed 3x squared. Okay. Again, you don't need to multiply that out. You can leave it as those two brackets like that. Okay. If there was like a follow-up question where you had to do more work, it might be beneficial to multiply it out. But if you just have to find the derivative, you can leave it like that. Okay, that's fine as it is. Okay, any questions on this one? Good. Okay, so the first bracket, that's your d by du. Second bracket, that's your du by dx. Okay, so again, that is d by du part, and this is the du by dx from the chain rule. Okay, next one, number 4. Okay, so we have g of x is equal to the integral root x to x squared e to the t sine t dt. Again, we've got a problem because the bottom part is a function of x and the top part is also a function of x, so we need to split it up. So, integral from root x to 0 e to the t sine t dt plus integral from 0 to x squared e to the t sine t dt. Okay, second term, that's fine. First term, we've got a problem because we've got the root x in the bottom part. We need to put that up at the top. So we can swap the bounds and then put a minus sign. So that's 0 to root x e to the t sine t dt plus integral 0 to x squared e to the t sine t dt. Okay, first term, we've got a root x at the top, so we have to do a u substitution, so let's call this u. Second one, let's not confuse anything, let's put that as a w. So first term, I'm doing a u substitution. Second one, we can call that a w substitution. So we need to do d by du, and then du by dx. Okay, so we've got the minus out in front. D by du, that means it cancels and we put u in place of t. So it will be e to the u sine u, and then now we need to do the d by dx, du by dx part. So u is root x, d by dx of that will be 1 over 2 root x. Okay, and we can leave that as our first term. That bit's done. Plus, second term, we've got the w there. So we need d by dw. So in place of t, we put w. Okay, that's the d by dw part. And then dw by dx. Since w is x squared, the derivative will be 2x. Okay, now we can't leave it like this. In place of u, we're going to put that original root x. And in place of w, we're going to put that original x squared. So we keep the minus sign there. So it will be e to the root x sine root x. this other part stays. Next one, that was x squared, so it will be e to the x squared, sine of x squared, and then the 2x stays. Okay. You can have both of them with a u substitution if you want. So you can use u for the first one and then later u for the second, or you can use separate ones. Okay. If it's too confusing using u for both, stick with different letters. Okay. But I like to use u for the first and then w for the second, then I know what goes where. Okay. Any questions on this one? Okay, so it's always the same method. You split it up, you make sure that your bounds are correct, so the bottom is a constant, the top is the function of x, and then you do the chain rule. Okay, next one, number 5. So we have g of x is equal to the integral from x to the natural log of x, e to the t over t dt. Okay, same thing as before. The bottom has an x, the top has an x. We need to split it up. So let's do that. So that will be the integral from x to something, but now we can't choose the 0. Because if we substitute 0, the top part will be a 1, the bottom part will be a 0. That's 1 over 0. That's a problem. So here we need to be careful about what we choose. 0, that's not going to work. So let's choose 1. Okay, that's a bit better. So e to the t over t dt plus the integral from 1 to the natural log of x e to the t over t dt. Okay, so for the quizzes and assessments, I will be looking at what you choose there. So don't just always stick with the 0. Sometimes that doesn't work and you will have marks deducted. Okay. For this one, x is at the bottom, we want the x at the top, we swap the bounds, we put a minus sign. So that will be minus integral from 1 to x, e to the t over t dt, plus the integral from 1 to the natural log of x, that can stay, e to the t over t dt. Okay, now we want to find g prime. For the first one, it's straightforward because it's just an x, it's not some function of x. So this will just be minus e to the x over x. Plus, for the second one, since it's a natural log of x at the top and not just x, we need to do a u substitution. So we call this top thing u, then we do d by du, and then du by dx. So d by du gives us e to the u over u. Du by dx is the derivative of the natural log, that's 1 over x. Okay, so this is minus e to the x over x, plus, and now we can put the natural log back. So wherever you have a u, you can put your natural log back there. So e to the natural log of x, those are inverses of each other, so we just get x. U, that's the natural log of x, and then 1 over x. Okay, here the x's can cancel, so we're left with minus e to the x over x, plus 1 over the natural log of x. Okay, again, you can leave it with the x at the top and the bottom, but like I said before, if there's any follow-up questions, it might be nice to simplify first. All right, any questions on that? Okay, so same thing as before. You split it up into the two parts. You make sure that your x is in the upper bound. If you need to do a u substitution and a chain rule, you do that. Okay, number 6. G of x is equal to the integral root x to root 2x square root 1 minus t squared dt. Okay. Same problem as before. We've got a function of x at the bottom, function of x at the top. We need to split it up into the two parts. So here, integral root x to 0. Do we have a problem with 0? No, we don't. If we put in 0, we get 1, so that's fine. If we chose 1, we would have 1 minus 1, which is 0. That's fine as well. Okay, so we have no problem with that. If we chose 2, then inside the roots we would have 1 minus 4, which is minus 3. And we can't take the roots of a negative number. So again, you need to be a bit careful about what you choose. Choosing 0, that's fine. Choosing 1, that's fine. Choosing 2, now we have a problem. Okay, so again, be careful about what you're choosing there. But 0, that's fine. Square root 1 minus t squared dt plus the integral from 0 to root 2x root 1 minus t squared dt. Okay, first term, we have the x part at the bottom. We want it at the top. We swap the bounds, we put a minus sign. Second part, the x part is at the top, so that's fine. We can leave it like that. Okay, so everything is sorted now. We've got the constants at the bottom of the bounds, we've got our x terms at the top, and everything separated nicely. So now we can take the derivative. So g prime, we have a minus. Okay, we need a u substitution, so we put u is equal to root x. So we have root 1 minus u squared. Du by dx, that's going to be 1 over 2 root x. Plus, second term, we can do a w substitution. So that's going to be root 1 minus w squared. dw by dx, that's going to be root 2 over 2 root 2x. Like that. Okay. Then we substitute our u, and then we substitute our w. Okay, so here we get a minus root 1 minus u squared, so that'll just be an x. 1 over 2 root x. Here we've got a root 2x, so that will be 1 minus 2x. And then here we get a 1 over 2 roots x. I think there's a root 2 at the top. Okay, something like that. Again, if you want to simplify, you can do that, but we can just leave it as is. All right, any questions on that? Okay, yes. Sorry? Yeah. Yeah, there. Okay. Again, if you can do this without the u substitution and the w substitution, so like if you can just do that part in your head, that's perfectly fine as well. But if you're not sure, please do the u substitution and the w substitution, because if you get the final answer wrong, you can still get part marks for that. Okay. But if you try to do everything at once and then you get it wrong, then I can't give you part marks. Okay, so again, if you're unsure, please show the individual steps. Okay, next one, number 7. So here we have g of x is equal to the integral from e to the minus x to e to the x, natural log of t dt. Okay, now here we need to be careful about those symmetric bounds. This is not minus a to a, because that minus there is in the exponent. Okay, if this was minus e to the x to e to the x, then it would be something like minus a to a. Okay, but here it's a bit different. Okay, so we can't use any of that even or odd function stuff. Okay, so just note that minus, it's in the exponent. There's no symmetric domain here to look at. Okay, so let's split it up. So g of x is equal to integral e to the minus x. If we put 0, then we have a problem, because the natural log of 0, that's going to be minus infinity. Okay, problem there. If we put 1, then the natural log of 1 is 0. That's fine. So we can put a 1 as our middle bit. Okay, but you can't put 0. That's going to be a problem. Okay, then we have the natural log of t plus the integral from 1 to e to the x natural log of t dt. Okay, or you could put 2 or 3 or anything like that. That works as well. Okay, it's just 0. There's a problem with that. Okay, now g of x. Okay, the x part over there is in the bottom. We want it at the top. We swap the bounds. We put a minus on. Second term, that's fine. Okay, now we can take the derivative. For the first one, we can call that top bound u. For the second one, we can call that w. So here we have a minus. So we have from 1 to u, if we do d by du, that cancels the integral. So we have the natural log of u, and then we need du by dx. So the derivative of e to the minus x is minus e to the minus x. Plus, again, d by dw, that cancels the integral, so we have the w inside, so it's the natural log of w. dw by dx, that's the derivative of e to the x, that's just e to the x. Okay, let's substitute. So u is e to the minus x. If we have the natural log of e to the minus x, that's just minus x. So now we've got a lot of minuses going on, so let's be careful. So the natural log of e to the minus x, that's a minus x. Then we have another minus here. The natural log of e to the x, that's just x, so no problem with that. Okay, so we've got a minus and a minus, that will make a plus. Another minus, that makes it a minus. Okay, so please check all your signs there. So that's a minus. Okay, so we have something like that. Okay, any questions on that? Okay, so everyone is comfortable with that. So the choice of 1, everyone's all right. The natural log of e to the minus x, everyone's all right with that. No issues. Okay, that was number 7. Number 8. Okay, 8, that is the integral from 1 over x to x, t squared dt. Okay, again, we've got a x term at the bottom, and at the top, we need to split it up. So g of x, that's the integral from 1 over x to 0. Quick check, if we put in 0, do we have any problems? No, so that's fine. dt plus the integral from 0 to x, t squared dt. Okay, first term, we have the 1 over x at the bottom, we want it at the top, swap the bounds, put in the minus sign. So that will be minus the integral from 0 to 1 over x, t squared dt, plus the integral from 0 to x, t squared dt. Okay, second term, that's straightforward to do. First term, we've got a problem with the 1 over x, we put a u substitution. So g prime, that's going to be minus. Since we did that u substitution, we replace the t with the u, so we get u squared. du by dx, u is x to the minus 1. When we take the derivative, it will be minus x to the minus 2. So we can write that as minus 1 over x squared. Okay, or you can leave it as minus x to the minus 2, that's fine as well. Plus, this next one, we don't have to do any u substitution, nothing to worry about. We just substitute the x. So it will be x squared. Okay, any issues with that? Okay. So it'll be minus u, that was 1 over x, so u squared, that will be 1 over x squared. Okay, minus and a minus, that makes a plus. X squared and x squared, that will be x to the 4. Okay, so we have 1 over x to the 4 plus x squared. Okay, any issues with this one? Okay, so I hope everyone's writing this down so you get 4 marks for the quiz. Right, any issues? Okay, that was number 8, 2 more to do. Number 9. So we have the integral from x to 1, e to the, x to the 1, e to the t dt. Okay, so that's our g of x. So we can swap the bounds, because here we have the x at the bottom, we want the x at the top. Swap the bounds, put a minus sign. So we have minus the integral from 1 to x, e to the t dt. So then g prime, that will be minus e to the x. Okay, no need for any u substitution, we're just using that FTC2. Okay, so the derivative and the integral cancel, we replace the t with the x. Okay, so no extra u substitution for that. All right, any questions with this one? Any issues with the working out? Yes. Sure. Okay, so here from g, we're looking for g prime. So g of x is the integral from 1 to x, e to the t dt. So g prime, that will be d by dx of the integral from 1 to x, e to the t dt. Now, FTC2 tells us that the derivative and the integral are inverses. So if you take the derivative of the integral, they cancel each other out. So this and this cancel, and then instead of writing e to the t, it now becomes e to the x. So here we substitute x. Where did we get that x from? That's from the upper bound. Like when we did the u substitution, it was the integral from 1 to u. Then we would put u in place of t. But here we don't need to do a u substitution, so instead of t, we just directly put x. So since the derivative and the integral cancel, it's just e to the x.
So what if the constant they was maybe 4 or 5?
Doesn't matter. Constant doesn't matter. So whatever that constant is at the bottom, it goes away. Yeah. So you can have any constant you like at the bottom. The only thing you need to worry about is having that x at the top. Okay. Any other issues? Okay. Last one, number 10. So we have g of x, that is equal to the integral from x squared to 0 cos of t dt. Okay. Same issue as before, the x squared is at the bottom. We want the x terms to be at the top. We swap the bounds and we put a minus sign. So g of x, that's minus the integral from 0 to x squared cos of t dt. Now, since it's x squared and not just x by itself, we need to do a u substitution. So we're going to have u in place of x squared. Okay, so g prime of x, that will be d by du of the integral from 0 to u cos of t dt, du by dx. So if you want to write it out fully, that's how you would do it. Okay, like we did on Monday. Now the derivative of the integral, they cancel. So wherever you have a t, you then put a u, because that's at the top part there. So that's going to be cos of u, and then the du by dx. We said at the top there, u is equal to x squared. If you find the derivative, that's 2x. Okay, but we're not done yet. We can't leave it in terms of u. We have to put that x squared back. Yes. Yes, negative sign. So there should be a minus there and a minus there. Okay, good. I'll give you some points for that. Just see me at the end. Okay, so again, we've got the u. We need to put that x squared back there. So that will be minus 2x cos of x squared. Okay, with the minus sign. Okay, yeah, be careful of those minus signs. When you swap the bounds, you put the minus. Make sure that you carry it down. Okay, so whenever you're swapping the bounds and getting that minus, make sure you carry it down like that. Okay, any questions on this? Okay, any questions on the FTC 1 or the FTC 2? Okay, good. Okay, so quite a few students got quite a lot of points here. This is 2, 4, 6, 8, 10. One student got 10 points, so that's quite good. And then a few other students got 6s and 4s and stuff. Okay, so that's quite good. So these points, they won't be for the quiz tomorrow. The quiz will be on its own. They will be for the assignment. The assignment also has bonus marks. So if you get above 100, then that will carry over to the class test. Okay. So the quiz, that does have some bonus marks available. Those bonus marks will be for the quiz and only the quiz. That will not carry over. Okay. So the maximum you can get for the quiz will be the 100. Okay. Any other points from this that carries over as usual? Right. Any questions on that? Okay, so that's all the revision we're going to be doing for this. Remember that not next week, that's the holiday, week after, that's going to be the assignment. Then we have some time for test revision. Then we have the test. A little bit more time to go over a couple things. And then the final test. Okay, remember the final test, that's quite a big portion. Okay, so there's a few more things we have to do for that final test. But up to this FTC 2, that's the majority for the class test 2 as well as the final test. Okay, so you can start preparing for the final test now. Okay, any questions about the schedule coming up? Okay. Okay, so I'll see you in the tutorial tomorrow.